up is down, what's left is right.
Hey there, and welcome to another channel video. Today I have a product that is on the market for some years, but FNIRSI asked me if I would like to review it. And to be honest, I was very curious about this product, and I'm talking about the DSO1013D tablet oscilloscope. The first oscilloscope that I review in this channel was the FNIRSI 1014D, a very popular desktop oscilloscope, but I never had the chance to review this one, so when the chance appeared, I promptly accept it. There is already a lot of reviews and opinions about it that I watch in the past, but I will try to do my best to be impartial and don't let me influence by those opinions. This video was not sponsored by FNIRSI, and FNIRSI just asked me to review it and sent me this device for test free of charge. Anyway, I want to thank FNIRSI for their collaboration, but also you that watch this channel and use product affiliate links in the description or the affiliate access links in the screen before paying your purchases on AliExpress or Amazon. You become a channel sponsor without spending a cent more. Thank you for your help. So, enough chit chat, let's do some oscilloscope testing. As always, let's start by seeing the box and what is delivered. It comes in this black box, nothing special, nothing fancy. Let's open it. Okay, so first of all, we have a set of two P6100 probes. Yeah, that's it. Let's take this out of the way. And we have also a user manual. Okay, this is the old format of the FNIRSI manuals. This product has already some years in the market, so it's not the new manuals, much more nice. Okay, we have Type C to Type A charging cable. This is the purple ones. And we have also, I think this is American, let me see, charging type power supply. Let's see. Yeah, this is that one that I think it's used in the United States. I'm almost sure. And also it was sent to me, this one, for European sockets. So let's take this out. Opa. Okay. So as first impressions, it is a lot smaller than I initially thought, but yet the screen is 7 inches, so that's nice. You don't lose a lot of space in the borders or anything else. You have more or less 4 centimeters from the front to the end. Yeah, on the top you have 2 B and C sockets. You have there the output for 1 kilohertz sine wave. So you have also the light for charging and the light for power. I believe this one is on when you are using the power directly on the USB Type-C plug. And finally you have this power button. One thing that I'm noticing from the first model that I see of these devices is that you have these sockets inside this hole, and you will have nothing on top of the plastic, so it will be not so easy to break or damage the sockets. So yeah, nice detail. It's improvement since the first version that I saw from this device. Right now it has the FNIRSI name, not the model anywhere. In the back we have this small stand. Let's see the inclination that we have. It gives you a nice inclination. Okay. So let's power this on and see how it works. So in terms of display, what you have on the screen, we have the menu button, we have the run stop indicator, so this is the trigger. In here we have the information of channel 1 and channel 2. Those are also menus, I will show you in a bit. We have here the horizontal time division, and if you are moving fast or slow, I will also show you what this is, and also the trigger menu. We have the battery indicator in the right side and the control button. We have some shortcuts here, the run stop function, also the auto set. So we have the vertical cursors here and the horizontal cursors. I don't know why the T and V, but voltage and time. Okay, so also the measures shortcut and save the screen and save the waveform. In the bottom you can have the measurements. Right now we have only 5, but we can have more. And in terms of options in the display, that's it. Now let's dig a bit more in the options that you can do while working with the device. First of all, for moving any option in the screen, as you can see, it is very responsive. It works really fast and image is also very good. For example, if you want to move the channel, you do it like this, channel 1, channel 2. Also in the memory, you just need to move to one place or the other. And if you want to change the time division, you press on this side of the screen or on this side of the screen to increase the time division. Okay, so we have this move fast and move slow. If you use the move slow, as you can see, this is moving much slower in the screen. Okay, if you use the move fast, it will allow you to move very quickly. So pretty simple to understand. We have the run and the run stop. You just press here. Okay, you have the shortcuts. Also auto setting, really easy to use. And in terms of the top menus, you have the channel. You can activate or deactivate each of the channels. So channel 1 on off, and you have also the FFT. You can turn it on or off. You have the coupling, DC AC, and you have the probe mode 1 time, 10 times and 100 times. So pretty intuitive. The same for channel 2. And we have also this menu for triggering. So for triggering, you have the auto, the normal one, you have the single and the normal. In terms of single, let's see how it works. Okay, run stop, and you are triggering the single menu. Okay, so let's put this in auto again. You have also the option for rising or falling trigger edge. And in terms of which channel we trigger, it can be channel 1 or channel 2. And as we change it, you see on the top, he will show you which channel is triggering. Okay, in terms of the top menus, that's it. We have also the main menu. In the main menu, you have system settings, where you can set the screen brightness, the grid brightness. Right now it's 73, 95. If you want always trigger at 50%, we have the baseline calibration, basically is the calibration of the device. And also if you want to use the XY mode display on or off. Right now it's off. So I will show you this ahead in the video. We have also the picture view and waveform view. I will also show you that, and the USB connection. In terms of menus and options, we are almost done. Just need to show you the control to increase the amplitude or decrease the amplitude of channel 1 and channel 2. Okay, and you have also here the 50% triggering, just to put you always at 50%. And in terms of options, I've shown you everything. As you can see, it's easy as you can get. So let me show you now the rest of the features. In terms of features, I will start by showing you the XY mode. As you can see on the screen, you have two sine waves of 1 megahertz, VPP 1 volt. Let's activate the XY mode. I think, yeah, that's it. Just press on the screen and you should have right now something like a circle. Yeah. Okay, so let's animate this. Let me change the frequency of channel 2 a bit. We have a nice circle rotating on the screen. We can increase a little more the velocity. And if you go back to channel 1 and change also the frequency, yeah, like this. Let me see, like this. Okay, you can have different figures like this. One thing that I'm noticing is that it renders pretty well. Let me do an auto set. Okay, it changed completely the figure. Let's increase. Okay, it seems like this, it's okay. So it renders pretty well. I don't see much jittery or flickering in this. Let's try another figure like this. Yep. So yeah, it seems to work okay. Okay, so another feature that is also present is the FFT. So let's activate this and we just go to the channel menu and open FFT option, and also on channel 2 the same. And this is something cool because you can have both channels with FFT in here, and as you can see we have the option to see what is going on. You can see the harmonics in here in both channels, and though that is one thing that it's pretty cool, you can activate FFT for both channels. I don't know if you can move the FFT. It seems you cannot. It will always be on the top. While we have this on the screen, I will press the save peak. Okay, it's saved, and also the save waveform. Both save information on the screen, but I will show you right now the difference between one and the other. So let's start by seeing the picture view. We have here the picture that we had on the screen while we were working, but you cannot do anything on this. Let's go back. If you had more than one, you can change between them with these keys, and obviously you can delete it. So you have several options here also to control the pictures that you take. Let's go back, and now let's see the waveform view, and it seems equal in everything. You have the same options, the interface is pretty much the same, but if you enter here you can use it to see what was the state at that time, and then you can control both channels. You can navigate in the memory like this. Okay, as I said before, this is pretty intuitive, and I don't know, I will check this now with you. If I disable here, yeah, pretty nice. So you can even disable and continue to work with this. Okay, you can increase or decrease the time division, and also the amplitude. Obviously it's pretty different from the picture. You can control everything in here. You can even see the time divisions. You can do whatever you want with the information that you saved, and it is pretty intuitive to work with. And I don't get tired of saying that this is so responsive. It responds so well. It's one of the best touch screens that I've had in terms of oscilloscopes in here. It responds really quickly and well. Okay, we are on stop. Let's go back, page up, page down. Okay, delete wave. We have here. And another thing, you can use measurements or save peak from the waveform that you had saved. You can also delete wave. So apply cursors and measurements on that. Really cool, this one. Okay, let's go back. and I think I've shown you what we have to see in terms. One thing, I disabled the FFT while watching the waveform, but it's still disabled here on the main screen. So nice detail. Okay, I think that we are done. This one is just used to download or upgrade the device, download images or upgrade the device. On off, if you want to take this, now you can connect the cable to the computer, and if you want to disable this screen, just press there. Okay, so let's disable the FFT, and I think it is time to test the bandwidth. So before testing the bandwidth, I already, to save time, I already compensated the channel 1. I will now compensate the channel 2 also. It's a little bit undercompensated. Yeah, now we have 90-degree angles in the signal, the square wave. So this is ready for testing. I'm just going to disconnect this and disconnect first the channel 1. And yeah, that's it. We are ready to start testing the bandwidth. Okay, my setup for testing the bandwidth is ready. You have on the screen also my function generator, the O1XDG to 2100. It's a 100 megahertz, 500 megasamples per second function generator. And I already, as I've shown before, compensated both channels. They are in time tense mode, both channels, and also the function generator is with the channels synced between the both of them. I will first start by testing one channel and then the two channels. Let's start by outputting the signal on channel 1. Auto set. Yeah, we have a nice sine wave. Very nice. Okay. 1 volt peak to peak and 100 kilohertz. Okay, I forgot to mention that I have 1 volt peak to peak. So if the bandwidth goes below 714 to 20, it should be less than the -3 dB. So yeah, something like that should be desirable over that millivolts. Yeah. Okay, let's start with 1 megahertz. Auto set. For 1 megahertz, we have a voltage peak to peak 1.10, and the frequency is recognizing exactly 1 megahertz. Very nice. Okay, as I showed you before, this is pretty easy to work with the signal. It is a little bit jittery, not perfectly drawn, but very nice even so. Okay, let's pump this to, I don't know, 25 megahertz, a jump to a fourth of the maximum bandwidth. Okay, we start to see a little degradation in the draw signal. In terms of drop, we have this right now with 850 to 70, 80 millivolts, so over the -3 dB, and it detects 24 to 25 megahertz, so okay, acceptable. Let's move on to 50. Let's half of the maximum bandwidth announced. Yeah, we are at 10 nanoseconds per division. The signal is better designed, and we still have the VPP in something like 900 and 800 to almost 1 volt, 800 millivolts. Yeah, something like that. Let's do an auto set. Yeah, it still is on 890 to 920 millivolts. It detects 50 megahertz, so very nice. And let's move this to 75 megahertz. Okay, 75 megahertz. I cannot increase, obviously, from 10 nanoseconds division the signal. I can make it smaller. but yeah. In terms of this is a little bit okay. This animation, it's a little bit weird. I think that you saw that. Okay, so we have 950 millivolts. Let's do auto set. 950 at 75 megahertz. Okay. And the square wave, the sine wave is properly drawn. So yeah. Let's move this to 100 megahertz. Oops, not 1000, just 100. Okay, so in terms of 100, what happened? Auto set. Okay, it is not being able to detect 0 volts. Okay. Okay, 50. Let's put this in 100 megahertz again. 100 megahertz. Okay, and let's manually go down 99 megahertz, 98, 97, 96. Okay, let's do an auto set to see if we are now at 95 megahertz, 94, 93. We should have something in it. Okay, we are with 93 megahertz. Let me increase to 94, 95, and he goes bananas. Okay, 94 again. It's still a little bit jumpy, not working perfectly. 93. Okay, in terms of in terms of frequency that it supports from the function generator output, it seems to be that 93 megahertz, it's the maximum that he can process. After that, he starts to lose the capacity of displaying anything. But we have a huge drop to 400 millivolts at 93 megahertz. It's recognizing here 92, but it's currently at 93 megahertz. So what I will do now, it's going down slowly, one megahertz at a time, to see until which frequency will correspond to the 700 millivolts. Let's do that. Okay, 91 megahertz, 90, 89, 88, 87, 86, 86, 85, 84 megahertz, 83 megahertz. Okay, let's do auto set. Okay, so we are in the 695 to 725 in terms of millivolts. Since we are using 1 volt peak to peak, this means that the minus 3B is around the 83 megahertz. So the real bandwidth of this device should be around the 83 megahertz. Okay, it's not what is announced, but even so, considering the price range and the competition of the other manufacturers of these products in China, I think it's up to the same quality level. So yeah, the part that I don't like a bit, it's not being able to work with anything, even with the voltage drop over the 93 megahertz. For me, that's a bit weird. But yeah, this is the maximum bandwidth that you can have with a voltage over 714 to 20 megahertz. Millivolts. Okay, so I have here already both channels using 100 kilohertz. They are phase aligned and same conditions as before. Let's start increasing the channel. I don't know why I had the trigger on channel 2. Let me pass to channel 1. And let's start testing both channels. Just taking this one off to make it okay. So let's start testing both channels in terms of bandwidth to see what happens. Okay, 1 megahertz starting now. In terms of 1 megahertz, and I still have 1 VPP in both channels, and my function generator is capable of producing 2 independent signals of 100 megahertz. Still 1 volt, yeah, seems okay. Let's move to 25 megahertz. I don't expect to have the same performance with 2 channels. In terms of 25 megahertz, we have around 820 millivolts VPP. It detects almost the 25 megahertz. Okay, let's move to 50 megahertz. Okay, and in 50 megahertz, let's do an auto set again. The signal seems very good, still above the 900 millivolts in both channels. This is almost too good to be true, but yeah, it's working fine. Let's move this to 25 megahertz. Okay, it has this weird draw while getting to the bandwidth. Auto set. Okay, so it's VPP 910 to 50 something. This channel is VPP 1 volt. I have to say that I suspect a bit from these readings, but yeah, right now we are, I don't know if they rewrote the board and we have now 2 ADCs, but okay, so let's move this to 100 megahertz. Same problem than before. Auto set doesn't seem to be able to read the 100 megahertz. I will now start going below 100 megahertz. 99, 98, 97. Okay. We have a different result with this with 2 channels. Right now I'm with 96 megahertz, and even if the signals are not okay, but at least they appear, and before it will not appear at 96 megahertz. Let's do a 95, 94, 93. Yeah, channel 1 it's more or less stable, and we have here some weird results. This one says it's 750 millivolts peak to peak. The bandwidth is 55 megahertz when it's not, it's 93. And in here we have 400 millivolts, and the bandwidth it's not 87, 88, it's 93. So let's diminish, go back a bit. Don't forget that the sampling of the device should be less divided by both channels. So okay, 90 megahertz right now. Let's do an auto set again. In 90 megahertz it's reading more or less correct the bandwidth and the frequency, not bandwidth, sorry. And we have 650 to 2250 PPP, and this one still has 480 to 99. It's reading 90 megahertz in frequency. We have different reactions in both channels, so this seems to to work better with both channels on than off. But okay, let's see which frequency will give us something like 700 millivolts. I will start going down. In terms of channel 2, we are already there, and that's weird. But okay, let's see what we have to do to go to channel 1 with both channels on. I'm now with 85 megahertz. Not here, not there yet. Okay, same result as before. So with 83 megahertz in both channels, I have 82 megahertz in both channels. I now have 750 millivolts, something like that, and 900 VPP millivolts in channel 2. So we have here different results. The frequency, it's the same in both channels. So what I will do now is stop the frequency sync and go to channel 2 and increase manually the frequency. Okay. Yeah, I think that's it. I'm now at 91 megahertz. Let me do auto set. This is very weird. Okay, I'm now at 100 megahertz. And what happens is that it seems that channel 2 is able to withstand the 100 megahertz with a VPP over 7040. Let's do auto set again to make sure. Yeah. And channel 1 is able to go up to 82 megahertz. Don't ask me how this works, because to be honest, I'm a little surprised. Okay, that's it in terms of bandwidth testing with both channels. It was a surprise for me, and let's move on. I have the oscilloscope in the operating table. It's now teardown time.
Fly so high, I'm hypnotized. What's up is down, what's left is right. Chasing stars and holding you.
Now it's the time to talk about this video sponsor, PCBWay. I always use PCBWay for creating my boards with a professional factory quality, as you saw in my millivolt voltage reference board. It is very cheap to manufacture your PCBs on PCBWay. You can manufacture 10 PCBs for only $5. How awesome is this? And it is pretty easy also. Just insert here the PCB dimensions and you'll have an instant code. So when you want a PCB, visit PCBWay to get your code, and if it is your first time ordering from PCBWay, you can use our access link for a $5 credit. And don't forget, they also have component assembly service, 3D printing service, and much more. Okay, here we have the boards already zoomed in. So let's start with this side. It's near the power button. We have here a CPEX 29302. The CPEX seems to be acquired by a company called MaxLinear, and the datasheet that I found, it was for a 3 amp low dropout voltage regulator. So here it is. And we have also near a pretty common AMS 1117. It's from Advanced Monolithic Systems. It's a 800 milliamps low dropout voltage regulator, also near. And in terms of electric and charging and everything else, we have also the TP4056. And this is the first time I see this happening, but we have two units, one of each side of the power button, one up near the battery connector and the other one near the USB connector. So those are 1M standalone linear ion battery chargers, and they have thermal regulation. Near this we have a processor that is common these days in these devices. It is a ARM9 CPU. This is a very nice CPU and a very cheap one, and it has a lot of stuff in it, and it is used in a lot of devices. Okay, in here we also have the Winbound. So this is a 16 megabit serial flash memory. It has dual quad SPI. Okay, so what else we have? We have the normal FNIRSI SD card for the operating system, I think, or storage. I don't know what is the size, but we can check. Let's see. Okay, it's a 8 GB memory card. And we have the connector for the screen, and on this I think this is the connector for the touch sensor that allow you to use the screen as a interface. Okay, over here we have a chip. This is a processor. I didn't find the datasheet for this one. All I could find was the manufacturer page. This is from Shanghai N-Logic Infotech, and it is a FPGA processor, but nothing much was found on this. Yeah, let's move on. Here on the side, I believe we had the ADC, two of them for each channel. They are scratched, so it's not possible to understand which devices we are using in here. And on the top, I only take one of these protections, the other one is still intact. So we have inside this protected area the sub-miniature signal relay from Hongfa. We see a lot of this in the oscilloscopes, these Chinese oscilloscopes, and in the top of this we have a high voltage photo MOS relay. So this is okay, also very common in these small oscilloscopes. I don't think I have much more to show because these don't have a lot of ICs. This one is also scratched. I think we have it covered. So let's zoom out. Okay, here you have the whole board. It has nothing in the back. It's totally clear. And yeah, that's it. In terms of screen display, we have the screen. It's this model, and the connectors are in here, the flat cable connectors. The battery doesn't specify because it should be glued the other side. It should have dimension, so I cannot tell you what is the capacity of this battery. Okay, let's assemble this again and finish the video. Let's wrap this up, and as I've been doing lately, I will start with the price of this device. At 129 euros or around $135, the price is starting to get near to the price of the 1014D desktop version or even some other options in the market. That said, I have to say that portable version with a 7 inches responsive screen like this one, at this price range, at least that I'm aware of, this is the only one. You might have some variants of this device in other brands, but in the end, we are talking about the same device. It is a fair price. Well, you have a 100-ish megahertz oscilloscope, really easy to work. It will take you a few space on your workbench, but still has a very nice 7 inches display and the minimum expected functions like the cursors, measurements, XY mode and FFT. In my opinion, I do see a lot of market for this device. The bandwidth. Well, I will not dig too much in this subject. There is a lot already written and talked about on this, and you saw the results of my tests. So it will be nice if the specs are up to the results in the tests. The ADC doesn't seem to deliver the 100 megahertz in my test, and I was expecting that already. So it was more like a confirmation. Even so, I was with such a low expectation from what I read previously and other reviews I watched. Since this device is in the market for more or less 3 years, that I was kind of surprised with the performance, especially with the 2 channels at the same time. It's a bit weird, the difference of frequency or the maximum frequency in the channels, both channels, but the overall experience was somehow positive. And one of the most common questions I got in the oscilloscope reviews is if this device will work for automotive analysis. Yes, it will. So if you love this device and are considering buying one, let me just suggest you that if you use the product link in the description or the access links in the screen for your purchase on AliExpress or Amazon, you'll be helping me with the channel and keep these videos coming. So, was this video useful to you in any way? If it was, help me spread the love and slap that like button. And if you are not subscribed yet, please consider that every week I receive new electronic devices to review. That's it for today. Thank you so much for your company, and I hope to see you in my next video.